Hey everybody, alright, let's take a look at this here. Let's look at this matching. So we've got determined from tree diagrams and tables the probability of A then B occurring, the number of favorable outcomes divided by the total number of possible outcomes, and the probability both A and B occurring, and lastly here, used to show sample space for a probability experiment. Okay, so D, if you want to find the probability of something happening, you can use a tree diagram or a table. Okay, this is a tree diagram down here, but it's just a way of sort of organizing everything that can happen in a given experiment. And I'll go into more of that down here. Number 2, the probability of A then B occurring, so that would be obviously E. This is the how you find the probability of anything happening. You take the number of favorable outcomes and divide it by the total number of possible outcomes. Okay, so that is just the very generic sort of basic definition of probability. Number 4 here, the probability of both A and B occurring, that would be this, so they're both happening. Okay, and 5, used to show the sample space for a probability experiment, so that is a tree diagram. Okay, sample space is the funny. It doesn't really make sense why it's called that, at least I don't know why they call it that, but this is basically saying all the things that can happen, okay? Used to show all the things that can happen for a probability experiment. So for example, if I was flipping a coin, just one coin, the sample space, there's only, like, what can happen? I can get heads or tails, okay? So the sample space for flipping a coin, there's two things, heads or tails. The sample space for rolling a die, just one, would be there's 6 things that can happen, right? On a die, it can land on a 1, 2, 3, 4, 5, or 6. So that's all this word means, is like, what are the things that can happen? Okay, let's take a look at the bottom here. Alright, we've got an experiment here. Someone's flipping a coin, okay, and rolling a 6-sided die. Alright, so this is a tree diagram. Alright, basically what it's saying is, on the coin, okay, if we were to flip the coin first, there's 2 things that can happen, heads or tails. Alright, that's it. Those are the only 2 things that can happen. And if we spin a die, or spin, or what is it? Or if we roll, why does it say spin? Anyways, if we roll a die, we can get 1, 2, 3, 4, 5, or 6. And the reason it's written twice is because, let's say if we were actually doing this, let's say we let's say we flipped a coin and got heads, and then we rolled the die and got a 2, okay? So if we started with heads, then none of these are possible, right? Because if we flipped a coin, got heads, and then rolled a die, these are the things that could happen. I could get heads 1, heads 2, heads 3, heads 4, heads 6, all the way up, right? So there's 6 things that can happen, all starting with a coin flip landing on heads, okay, and then an individual die roll, okay. Down here, let's say I got tails on the coin. Well, tails on the coin, and then again, one of each of these 6 outcomes is possible on the die. T1, T2, T3. So this is saying tails and then 1 on the die, tails and then 2 on the die, right? So there are 6 outcomes here and 6 outcomes here. So in total, for this experiment, there's 12 things that can happen. 12 unique things that can happen when we flip a coin and roll a die. Okay? Now, once you have these, you can answer these questions. So, what is the probability of getting heads on the coin and then a 6 on the die? Well, we just look at our outcomes. And how many of them have an H and a 6? Just 1. And we said there were 12 in total. So the answer is just, there's a 1 in 12 chance of getting heads on the coin and 6 on the die. Alright, letter B here. What's the probability of getting tails and an odd number? Alright, so tails and an odd number. We could have tails and a 1, tails and a 3, or tails and a 5. Those are the only ones that have tail followed by an odd number, 1, 3, and 5. So there are 3 of them, again, always coming out of the total of all the things that can happen. So that's why this 12 keeps reappearing, okay? This is the total number of things that can happen, and these are the favorable outcomes that we're looking at. So there are 3. So there is a 3 out of 12 chance, or we can reduce it, a 1/4, 1 in 4 chance of getting tails on the coin and an odd number on the die. And then the last one here, what's the probability of getting heads? Okay, and a 7. Well, there are no 7s on a die, so the chances of this happening is impossible. It would never happen. So there is a 0% chance that you would get heads on a coin and then followed by a 7 on the die, because this is only a 6-sided die, so obviously a 7 is impossible. So we would just say, you could honestly just say impossible. Okay. Alright, let's take a look at the next page. Oh, there isn't a table on this. Alright, let's take the first look at the first question here. A 4-sided die labeled 1, 2, 3, 4, it's this triangle sort of die, is rolled, and a spinner with a 3, 6, and 9 is spun. Okay? Create a table to show the sample space. Okay, so there's a lot going on here. Basically all you do, and I didn't make a table because sometimes the table versus tree diagram, it's kind of like pick one, and then kids get a little bit confused, like which one is right, and even though they both work, sometimes I find if you can just look at the situation and write out the sample space, that's these things in brackets, of all the things that can happen, it's sort of like, then you don't have to worry about making a nice looking table, or sometimes tree diagrams can be kind of hard to draw, especially in a small space like this. So I just kind of fast forwarded for simplicity's sake, and if you can do that, I suggest doing that as well. So basically all I did is I took, if I rolled this die, okay, it has 4 sides, 1, 2, 3, 4, and then I spun the spinner, so I just took, let's say I rolled a 1 on this, okay, 1, 1, 1, and then I spun the spinner, I could get 3, 6, 9, okay, so these are the 3 outcomes that could happen if I rolled a 1. If I roll a 2 on this die, again, 2 followed by each of the spinner results, 3, 6, 9. Roll a 3 on the die, followed by the spinner results, and lastly, rolling a 4 on the die, and the 3 unique spinner results. Okay, so there are 12 things that can happen. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so once you have that, you can answer any questions you are asked, essentially. What's the probability of getting a sum of an even number? In other words, if we add whatever we got on the die plus whatever we got on the spinner, what's the probability that when we add those two numbers we get an even sum? So all I did here in red is added these up. 1 plus 3 is 4, 1 plus 6 is 7, 1 plus 9 is 10, and so on. So how many of these are even numbers? Well, you just count them. You can probably figure it out. There's probably half of them, so the answer is 6, but if you're not sure, 1, 2, 3, 4, 5, 6, right? You've got a sum of 4, sum of 10, 8, 6, 12, and 10. So there are 6 that are an even number. There are 12 total outcomes. So in other words, there is a 1 in 2 or 50% chance that you would roll this die, spin the spinner, and get a sum equal to an even number. Okay? Let's look down here. Each week Sam, represented by H, because we're dealing with a coin, so heads, and Lacey will be the tails. Choose chores by flipping a coin and spinning a spinner. Okay? So we've got a coin here with 2 outcomes, and a spinner with 4 equal outcomes. Dishes, laundry, vacuum, and garbage. Alright. The sample space, I'm just going to do kind of what I did up here. If Sam flips heads, then he's going to have a choice of one of these 4 chores to do. Okay, so heads followed by dishes. Heads laundry, heads garbage, heads vacuuming. On the other side, if Lacey flipped tails, then she's going to have tails, 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 followed by, again, each of these unique outcomes on the spinner. Dishes, laundry, garbage, vacuum. Okay, so these are all the unique things that can happen. What's the probability that Sam will have to do dishes this week? So, how many of these outcomes have Sam, represented by heads, doing dishes? 1. And how many things are there in total? 8. So there is a 1 in 8 chance that Sam will have to do dishes this week. Okay, let's take a look at the next column here. Okay, for this one, in this game, there are 2 identical sets of 6 cards. You pick up a card from each set. The idea of the game is to make a sum of 10. Okay, so the cards are 7, 4, 1, 3, 4, 9. All right, create a table to show all the combinations. Okay, we're not going to do that. And the reason we're not going to do that is, first of all, we need way more room than this. Basically, what you'd have, it's almost like you're rolling 2 dice, okay? Because there's 2 stacks of these cards, so it's just like having 2 dice, each with a different thing on each of the sides. So what you got to do is realize that there's a bit of a shortcut here that we can take when we're finding probability of events like this. Let's take a look at number 7. 4-sided die and a spinner with 3 choices. So there's 4 things that can happen on this one and 3 things that can happen on this one. When we multiply those together, we get 12. So we know how many outcomes there are, right? 4 times 3, so there's 12 here. Down here, the coin had 2 things and the spinner had 4. And when we multiply 2 times 4, we get 8 possible outcomes. So we can kind of use that shortcut to figure out how many total things can happen. So if there is 6 in one stack and 6 in the other, there are how many total outcomes? 6 times 6. There's 36 possible outcomes, and clearly I don't have enough room to write those all down here, and it can be sort of a daunting task sometimes to write them all out. Now, let's fast forward to part B here. What's the probability of getting a 3 followed by a 3? Okay, so how many 3s are in this first set of cards? There's just 1. And then how many would be in the second? Again, just 1. So what would be the probability of getting a 3 followed by another 3? It can only ever happen once. So the answer is actually, there's a 1 in 36 chance that if you drew a card from one stack and the other, that you would get a 3 followed by a 3. And if we were to write out all 36 possible outcomes, you would find that it only ever happens once. We'd have 36 things written down in brackets here, a bunch of them, and you'd only ever have a 3 followed by a 3 one time. Okay? Okay, I did it. I did it anyways. I'm a rebel. Here's all the 36 things that can happen. Okay? The first number is the first deck, the first set. So you could get a 7 in the first one, and then in the second set, 7 again. Okay, so this first column, or the first number in each of these set of brackets, is the first set of cards. So you'll notice I have them all. 7, 4, 1, 3, 4, 9. Okay? 7, 4, 1, 3, 4, 9. Followed by all of the things that could happen in the second set. It's the same numbers because they're identical, right? 7, 4, 1, 3, 4, 9. 7, 4, 1, 3, 4, 9, and so on. So this is 36 different things that can happen. What's the probability of getting a 3 followed by a 3? It only happens once. So out of all 36, 3 and a 3 only appears one time. So that's why it's 1 out of 36. Okay? I just thought I'd show you that because, yeah, that's important. Okay, let's look at number 10. Trey chooses his outfits by spinning this spinner twice. Pretty cool, Trey. The first spin is for the color of his pants, and the second spin is for the color of his shirt. Neat. Okay, so there's 4 different colors: khaki, blue, black, brown. Okay, the sample space. We're going to use this little trick here that I showed you. So if he spins it once, there's 4 things that can happen. If he spins it again, there's 4 things that can happen. So there are 16 total outcomes. Okay? So now that we know that, we could write them all out, but now we know we're dealing with the total of outcomes, like the sample space, so we're good to go. Alright, B, what's the probability of him getting the same color? So we know there's 16 things in total that can happen, and same color would be if he spun khaki khaki, blue blue, black black, or brown brown, right? So how many things did I just say? 4, right? 4 outcomes where that's matching, that's matching, that's matching, and that. And we know that it's out of 16. So the probability of him getting the same color is 4 out of 16, or we can reduce it to a 1 in 4, 25% chance. That's so Trey could be wearing like really ugly, clashing, just solid khaki on a particular day if he's not careful, and there is a 1 in 4 chance of him having matching pants and shirts. Okay, so hopefully that makes sense. If you have any questions, don't hesitate to email me, and yeah, have a good day.